Such a pleasure to be here. And I'm so happy that we're still able to be together despite some of the news. So really a pleasure. So we're going to be, I should have an image here that looks like it's not showing up. So if anyone can check the slides, that'd be great. So in this talk, I'm really going to be focusing on artificial intelligence as a technology that's changing incredibly rapidly, how it works, and how, okay, now the clicker's not working? And how we can hopefully start understanding and wrapping our heads around what artificial intelligence and its already and soon to be even more widespread use is going to mean for crime, financial crime, and what we can do about that, what that will mean for new financial technology and innovative financial technology to interact with that. Okay, so clicker's still not working. Okay, great. Also, the timer's not going down, so it would be great if we could get that going too, because I don't want to stand in the way of a break for too long. Great, thank you. So, Dongming Zhu, the woman whose face you can see here, she is actually one of the most successful businesswomen in China. She's the founder of Gree Appliances and an incredibly successful, wealthy businesswoman. And her face is there because she's actually being disciplined. In certain regions in China, if cameras on the street catch you committing a crime, they put your face up on a billboard and they say what crime they've caught you committing. And jaywalking, walking against traffic in China is a crime. And so Dongming Zhu was caught for jaywalking and her face is on this billboard. But if you look closely at the picture on the left, you'll see her face was actually a poster on the side of a bus. And so you've got these buses, her face is a part of the poster for her company on the bus, and the cameras in China have artificial intelligent algorithms that recognize the face, know who it is, see that that face is moving against traffic, and flag it as jaywalking. And Dongming Zhu is luckily a person of great means. She and her company put out a notice saying they're thankful to the police in China for all the work that they're doing to keep society lawful. And she's been fine. But the thing to recall here is that there are places in the world where right now, artificial intelligence, facial recognition are being used to support law enforcement, and AI can make these mistakes. And so the more that we start to become aware of how these technologies are being used and the more we start to use them in industry, we'll recognize these mistakes and be able to improve our technology faster. And deep learning, which is a particular brand of artificial intelligence, and the reason that AI is advancing so quickly today is that we can finally use deep learning. So deep learning was actually invented in the 50s. And at that time, it didn't work because we didn't have enough data and our computers weren't fast enough. But that's changing. So right now, companies, governments across the world in every sector, from FinTech to pharma to agriculture to retail, are starting to use deep learning. And Kathy Wood, who's actually a dear friend and mentor of mine, and she's the #1 ETF investor in the last 5 years, according to Bloomberg. Her ETF ARC actually beat the S&P by 3.4x in the last 5 years. Kathy is, her fund ARC publishes incredible open research around innovation. And her work is really focused on innovation. So in 2020, her firm published their big ideas for 2020. Every year they publish their big ideas. And the first big idea of 2020 was deep learning. And she says, deep learning is going to be 3 times more impactful than the internet. What does that mean? So she's an investor, an economist, and she says, look, in the last 20 years, the last 2 decades, from 2000 to 2020, the internet has given us $10 trillion of value. So think about Amazon, Google, Microsoft, and more. We've had $10 trillion of value. And she suggests that between 20 and 2040, we're going to see $30 trillion of value from deep learning across industry. And so this is already happening and it's increasing exponentially. So it's so important to be aware of this trend and to understand how it can be used to create that value and also how it can be used to commit crime. So, Juniper Research Networks is predicting that by 2024, data breaches are going to cost our global economy $5 trillion. So even as new technologies add an incredible amount of value to the economy, we're also going to see these technologies used by criminals to help them do their work. And so the first thing we need to do is be aware of the technology and understand how it can be used for good. And so let's get into that. Now, artificial intelligence, it's not going to create $30 trillion of value by being in one industry or one field. A great thing to compare it to is electricity. We use electricity everywhere for so many things that Thomas Edison, the Wizard of Menlo Park, and others would never have been even able to guess. And AI, artificial intelligence, we're going to see it again across industries. Any industry you can think of, we're going to see folks using artificial intelligence, whether it comes to helping to support loan teams decide who they're going to give mortgages to, or whether it comes to designing novel drugs to fight novel illnesses. Now, I have a question for you in the audience. I want to ask you, would you rather have a penny a day that doubles every day for 30 days, so that grows exponentially for 30 days, or $1 million? How many people would like the penny? Okay, how many people want the $1 million? A lot of you are not raising your hands. You don't want anything? I mean, come on. So if you got the penny, who would want the penny, right? It's 1 cent, 2 cents, 4 cents. I might have given this away. But on day 28, you actually get $1 million. And by day 30, you get over $5 million if you pick the penny. So those of you who picked the penny, good job. And this is important because it's really, really hard as humans to wrap our heads around exponential thinking. So I'm coming here from Singularity University. And for those of you who are familiar with it, Singularity University is really focused on helping us to start to understand exponential growth of technology. And if you look at this graph right here, you'll see that at any moment when we zoom in and we're in the moment, we think of progress increasing linearly. So you can see that red line. Those are and those of us who are futurists, who spend all our time in the technology, maybe we can get to the orange line. Even AI researchers regularly underestimate how fast AI is moving because it's an exponential technology. It's so hard to think exponentially. There's this wonderful story that comes from, it's a myth from China. And how many of you have played chess? It's a pretty fun game, and at one point chess was invented. So the inventor of chess, so goes the story, the inventor of chess was a great general for an emperor in China. And he invented chess, and it was the emperor's new favorite game. And so the emperor wanted to reward the inventor of chess. And so what the inventor of chess says is, he says, look, what I want you to do is give me 1 grain of rice that grows exponentially on each square of the chessboard, each new day. And you remember what happens with our penny that doubles every day for 30 days. So the first day, 1 grain of rice, and the emperor kind of laughs. Second day, 2 grains of rice. You can see on the board right here. And as this grows, by the time you get to the second half of the chessboard, after you get past those 32 squares, you're on square 33, that amount of rice, so goes the story, would have bankrupted the emperor of China. And so he cuts off the head of the inventor of chess. And so when you're on that second half of the chessboard, it's really hard as humans to wrap our heads around how fast things are changing. Because a lot of what we have to do day to day is linear, and that's how our brains are wired. And so when you're on the second half of the chessboard, it becomes harder and harder to predict how fast things will change. And so we can see that when we think about when we think about how quickly these new technologies will matter to us, whatever job we have, and also when we think about that value that might be generated from these new technologies, which is why I find Kathy's point so compelling because she's willing to predict 30 trillion of value. And maybe she's wrong, but she might also be wrong by predicting too little. And that's what is really important when, again, we start thinking about the future. So we're in the middle of this revolution when it comes to software. The software that we all use every day, if you've got your mobile phones, they're incredibly powerful. Each mobile phone that everyone in this audience has, the computer inside that mobile phone is more powerful than the computers that got us to the moon. We're all carrying them in our pockets. But for the most part, today, they're still using software 1.0. So with software 1.0, that's how software typically works today. The IT departments in many of your companies, they're gonna be helping you with software 1.0, where you take a big problem, like that problem of, hey, how do we get to the moon? Or the problem of, hey, how do we predict if this person's a good credit risk? And you take that problem, you break it down into smaller problems, you write algorithms to solve each problem, and then you stitch them together in systems architecture. That's how software has worked for a long time. And part of why software has worked that way is this is actually an efficient way of using computing power. So as powerful as our computers are, our human brain is exponentially more powerful than even our best computers of today. And so we have to find ways of programming computers that can take advantage of their relatively slow speed and their relatively low power. Artificial intelligence, deep learning. If people ask you about artificial intelligence after this talk, you say deep learning, you're ahead. So you want to remember that. But artificial intelligence, deep learning, that's software 2.0. Instead of taking a big problem, breaking it down to smaller problems, creating algorithms for each small problem, stitching together systems architecture, instead you take data, lots and lots of data, you take computational power, lots and lots of computational power, and then you have algorithms, and those algorithms are actually free and open source. So a lot of people think for artificial intelligence what matters are the algorithms, but the algorithms are actually the easy part. The hard part is the data and the computational power. When you put those three things together, you get a new way of solving problems, software 2.0. We're gonna get into that. Before we get into that, I wanna share with you two exponential trends in AI that are incredibly powerful. So first, how many of you have heard of Moore's Law? So Moore's Law is the idea that the amount of processing power on a chip is gonna double every 18 months. So that means that our computer power has been growing exponentially, which is part of why the cell phones in our pockets can be more powerful than the computers that got us to the moon in the 60s. Moore's Law is every 18 months. The amount of computational power that we can put towards AI models is doubling every 3 to 5 months. So that means that AI, the ability of AI models to solve problems, remember, it depends on that computational power, that is growing exponentially faster than Moore's Law. And so we've had is a 300,000 times increase in our computational ability for AI since 2012. And that is enormous. And we're only beginning to see the traces of that in industry right now. The other thing that's happened is the cost of that computation has been decreasing exponentially. So more power is available, and applying that computational power to your problems is cheaper than ever before, and that cost is continuing to decrease exponentially. And so that means that you don't have to have the biggest supercomputer in the world to solve AI problems. You don't have to have all the money in the world. And so there's the democratization of access to deep learning now across industries and across the planet. And so what that means is that we can accomplish more with AI than ever before. But I do want to flag what we're talking about right now is narrow artificial intelligence. So how many of you have ever watched Star Trek? If you remember Data or the Doctor, the Doctor in Star Trek Voyager, those are generally artificial intelligent algorithms. So the Doctor, Data, they can do a lot. They're, if anything, smarter than a human in lots of areas. But the AI we have today, as powerful as it is becoming, is what's called narrow artificial intelligence. And that means that AI can do one thing. So if you're a human, I teach you to play chess, And then I teach you to play Go, I teach you to play checkers. You're gonna get better at playing games generally. An adult is pretty fast at learning a new game. But if I teach a computer to play chess using AI, that computer can't play anything else. It can just play chess. If you have an AI that's really good at predicting credit scores, you're gonna need a different AI to help you read receipts automatically, right? So it's important to remember that our AI, the kind of AI that's exploding in industry today is narrow. Now I just told you it's really hard to predict the second half of the chessboard. I think general artificial intelligence, the artificial intelligence that's smarter than a human in every way, I think that's 15 years out. But I could be wrong, I could be too conservative. Maybe it's closer. I'm told I'm very optimistic and aggressive on some of these timelines, but I could be wrong. And things are moving quickly. But this is important because for those of you who might be worried about losing your job to AI, the reality is that the AI that's going to work best is going to have humans in the loop. And we'll get into more of why that is to fight crime in a moment. So for narrow artificial intelligence, how many of you have used Facebook? Some of you. Have you noticed that in the last year and a half, the AI recognition of the photos has gotten a lot better? Now you know why. Even in just the last year and a half, the access to computational power and the access to cheaper computing costs has even helped Facebook. And remember, for artificial intelligence, there's three important things. There's computational power, there's data, and there's models. And for Facebook, every time you've uploaded a photo to Facebook and you've told Facebook who's in that photo, you've been providing Facebook with gold. That's the data that Facebook uses to develop its algorithm. So Facebook has billions and billions of pieces of data to develop its AI, which is why it's so powerful today. So how does its AI work? And this is our best understanding of how the facial recognition deep learning algorithms really work, what they rely on. So when you're a human and you're looking at face, we've actually got a particular area of our brain that helps us recognize faces. And we don't fully understand the kinds of algorithms that your brain is running to recognize faces, but human brains are optimized to recognize human faces. A Facebook algorithm that recognizes faces, as far as we can tell, it does it by understanding the morphology of the face, understanding certain points of a face and how distant they are from other points. And you can see the image of that here. And we've all got distinct facial morphology. And so that's how this algorithm, as it's trained on billions and billions and billions of pieces of data, can become really good at recognizing faces. What's fascinating is that you can teach deep learning algorithms not just to recognize human faces, but to recognize individual fish faces, to recognize individual cow faces. So there are agriculture companies that are working on creating more sustainable fishing farms using artificial intelligent algorithms that monitors the fish and knows which fish is who and can decide how to change the amount of food being given to fish. It's pretty incredible. So, although you're not going to be able to use that same algorithm to recognize fish faces and human faces. It's artificial narrow intelligence, so you're going to have to pick what you want to train the AI to do. So how do you build a machine learning model? You need raw data, and you have your model, but to take the raw data and make it effective, you actually need to label that data. We have to teach machines how to see. And the amazing thing about institutions, financial institutions, is access to tremendous amounts of proprietary data. So this is a world where in a lot of ways, incumbents have an advantage to startups. Because if you're a startup company, you have to figure out where are you gonna get your data. But large companies have that data. And so with a deep neural network, the reason this can become so successful is you have your inputs. So think about Facebook, right? We've got all these photos, they're being labeled by people. And to get an output of who's in the picture, you have lots of layers. And that matters because each of the different layers of neural networks can pull on different features, and we, as observers, don't even know what's going on fully in the layers. We see the inputs, we see the results, and the way we improve the network is we feed it more data. So to kind of share again the difference, if you're thinking about understanding a sonogram and knowing if there's cancer in that sonogram. For software 1.0, you take your hard problem, is there cancer here? You break it down into lots of small problems, irregularities here, irregularities there, create algorithms to solve each small problem, write lots of code, stitch it together into systems architecture, you get some software. It's clunky, it can break easily. With software 2.0, you have radiologists label data, and you use that to train models. And now we're getting to a point where there are software to find cancer that's starting to be approved by the FDA. We're getting to software for various medical applications that are better than a human doctor alone. And so that's a really powerful shift in how we build software. So if we go back to Facebook's facial recognition, it would work the same way. If I want to recognize faces in the traditional way, I'm going to have to break down the problem. It's almost impossible. But with software 2.0, lots of labeled data. We've all been doing the labeling, lots of data. You can get really incredibly powerful results. And so the key here is the labeled training data. And that's so, so important because it's really the heart of effective machine learning. And so when it comes to building applications for good and building applications for evil, labeled training data is going to be key. And when it comes to regulation, you're going to want to think about how do you audit and understand the labeled training data that goes into feeding models as those models become used across industries or become used in finance. And the other thing that's happening is we now have tools that are allowing people to label data and feed that data into models without having to know how to code. So that's what we're building at Labelbox. And so it's pretty incredible to see how there are now these new tools that can make it even easier to build deep learning. You can see on one side, there are folks labeling imperfections in a solar panel. On the other side, there's machine learning going on in response to customer success. Because you might want to automate a lot of interactions with customers if you have access to deep learning. And so if you're going to think about an AI-enabled business, you're going to need data. And I've got some examples here that are relevant to the financial services industry. If you want to automate claims being processed, or you want to make risk assessment models, or you want to figure out the risk of a client profile, you can start doing that using software 2.0. And again, AI is one of the most exciting areas of new technology today, and the successful businesses of the future will use AI. But what does that mean, and how do we keep our businesses safe in that world? So just as you can use AI to build incredible things, you can use AI for new crimes that you would never have imagined. So OligoSnoop is a hack that compromises DNA printing facilities. So if you take a DNA printer and you get sound, a sound recording of the sound of that DNA printer, you can use AI algorithms to figure out the ATCG sequence of the DNA. And so if you're a biotech company developing synthetic DNA to solve a problem, you might be spending $50, $100 million or more developing your synthetic DNA. And if a hacker comes in and just gets a sound recording from where the facility is happening, then your IP can be hopelessly compromised. And this is important because as we think about security in a world of AI, we have to think about protecting data that never would have been an issue before. Because metadata can be used in ways that we could never have imagined and we could never do without AI. So one thing you might think to say is, look, well, let's use AI to protect us. Let's start using AI to help us have better security. And we should definitely do that. So Darktrace is one example of a company that has some pretty incredible smart AI to help you understand your systems. So if you're a bank and you want to understand who's trying to penetrate your systems, where your data is, and the immune system of your organization, and when an intruder might be coming in, this new kind of AI security technology is very powerful. But AI is not perfect. So I bet every of you can tell the difference here. I mean, I can't always tell, especially if I'm in the back, but I bet all of you can tell which are the Chihuahuas and which are the blueberry muffins. But so shockingly, as smart as AI is, Our narrow AI will still make mistakes here. And in fact, there's something called a generative adversarial network. So a generative adversarial network is you take one AI and you say to the AI, hey, your job is to tell the difference between the chihuahuas and the blueberry muffins. And you say to the other AI, hey, your job is to tweak the data, so it's really hard for that first AI to tell the difference. And so you can make changes that an AI can't see that a human can. And that's part of why I think all of your jobs are safe, because, and we want to think about this from a regulatory perspective as well, the most effective AI is going to build in humans in the loop and build in security that has AI and humans working together. And so we're living in a world where more and more data about all of us is out there. And again, that labeled training data is the new gold. And in the past, this is actually a photo of the Berlin Stasi Museum. So the Stasi in East Germany, they spent a lot of time recording information about potential enemies of the state, pretty much everyone in East Germany. The amount of information Facebook has on all of us, each and every one of us, whether or not we're on Facebook, these guys would have been really jealous. So I have a video to show you. If we can start the video. Okay. We might be having a challenge with the AV. Can we do the video or no?
I'm looking to our technical.
Okay, I'd love for you to see it, but if not, we'll. Can we do it or? Oh, we can't do it. Okay. Well, the point of this video is everybody goes into people go into a coffee shop, and the person at the coffee shop has a little headset. They're talking to folks in a truck outside. And so people come into the coffee shop, the folks in the truck outside do research. And the person handing out the coffee, basically it says, hey, like our Facebook page for a free coffee and a pastry. And so you like the Facebook page, you get a free coffee, and they know your name, and they know your religion, and they know your job, and they know your parents' names. And so the idea is, look, it's really weird if you go to a coffee shop, people know all that stuff about you. When we go online, folks have access to incredible amounts of information about us. And if they have access to it, hackers have potential access to it too. So when we think about the future of financial crime, we have to think about AI and impersonating people in a way that's really difficult for us to distinguish, especially as AI gets really good around voice and as all this access to information about people becomes so readily accessible to hackers. And what's interesting about Facebook is we don't necessarily think about the risks here. Mark Zuckerberg obviously thinks very highly of the people who share information with him. So this is a conversation that he had with a friend at Harvard in an indictment. This information came out. And Facebook has recently been fined $5 billion by the FTC just this past July. $5 billion for criminally lying about how it shares information about users. And so there's this real question right now, how will the big tech companies, the FANG companies, come into financial services? Will they be opening banks? Apple now has a credit card. Financial services companies come from a heavily regulated environment, which is an advantage when it comes to keeping people safe in a lot of ways. And so there's really an opportunity here, I think, to create innovative products while still keeping people safe. And then finally, before we break for questions, I do want to share blockchain technology. For all that you hear about cryptocurrencies and them potentially being used to launder money or being used by criminals, and if I had time, we'd talk about it more deeply. Blockchain technology is really powerful because it provides us a radically new level of security for how we share and store information on the internet. And so when we think about protecting ourselves in this world where technology is changing so rapidly, this technology is actually extremely, extremely powerful for supporting new kinds of security. And so with that, thank you all. Such a pleasure to be here, and we'll take some time for Q&A. Thank you.
So let me just remind you that you should take out your mobile devices if you want to send up questions. We can't see your numbers. We've heard a lot here about the touches on data privacy. We can't see who you are out there, but you can send in questions. And then you select the agenda item on the agenda on the homepage, and then find this session, which in this case is the special presentation, The Future of Financial Crime and What It Means. And then if you scroll to the bottom of the screen and send in your questions, I'll get them on this tablet, which I just got the password to, so that's really good. So you touched on many, many things and the kind of revolution that's happening. And a couple things come to mind from where those of us who are in the financial services industry sit. First of all, the promise and the limits of financial inclusion. And when I ask that too, I kind of am thinking that, we have a potential to deliver inexpensive financial products to the unbanked. We also have the potential to keep people out of the financial system because they are suddenly undesirable in some way as a result of how we look at the amount of data that we've collected about them. So I don't know if you have some thoughts.
So I think that the promise and potential is that ideally, if these technologies are used well, you can vastly lower the costs of interacting with new customers, because you can take each person that you would currently have on a committee. They can be supported by AI to be much more productive and do a lot more. That said, when it comes to financial inclusion, it's tricky because there's regulations around which data you can use and which data you can't use. And so AI algorithms become much more powerful the more access to data you have. But if you use data that you're not allowed to use to determine access to a financial product, that can be really problematic from the regulatory perspective. So I think regulators need to really be reflecting and potentially revising what data can help to drive these decisions in order to support this technology to allow financial institutions to bank more people.
Well, it's interesting because you're talking about the data that's collected and what we do with it, and it leads to that whole question about, and maybe put you on the spot, you're a lawyer, so you're used to being on the spot. But the U.S. arguably sort of is lagging in terms of data privacy standards compared to, say, Europe. And where are we on that? I mean, the data's all out there, right? It already exists. So it's a question of where it's going to be stored, who has access to it. And you did kind of mention bringing in the regulators, but.
So I would say that the mistake that Europe is making, so the GDPR, the General Data Protection regulations, they're really based on Germany's data protection laws. And I shared with you that photo of the Stasi Museum. In Germany, they remember East Germany, and there's much more of a focus on privacy. Privacy is a human right in the European Constitution. All of that said, I think the GDPR regulations are also designed to be anti-competitive for US companies. And there's some good to that, but there's also some bad to that. So there are unintended consequences. For example, if a car is hit, if you end up in a car accident, if you could have free access to data, you could immediately call an ambulance with a smart system in a car. That becomes really difficult to actually achieve from a GDPR perspective, because a person's been in an accident, they can't authorize you to share the data in that moment. And so, I think that it's really tricky. It's important and crucial, and we need to be thinking about it and having that conversation about how do we protect data privacy while still supporting innovation, growth, and artificial intelligence applications. And I think that we can learn a lot from Europe, but I also am hopeful we can avoid some things that in their rules actually make it a lot more difficult for innovation.
Yeah, so that the U.S. maybe hasn't considered this enough, but we need something not quite like Europe.
Yeah, exactly.
So we have questions coming in, and somebody's asking you to kind of weigh in on where the government regulators are. I think there's always a question, is there enough know-how and savvy within government around these technological issues? And I don't know if you want to go there or talk about that, how government would get that, or if some of the government agencies, people have actually asked, are there agencies that you think are getting it within the regulatory framework?
So I think one of the really tricky things is that these AI questions are not in a vacuum. So we live in a globally competitive world. And I showed you that photo of Dongming Zhu from China. It's humorous, but what is important is that the Chinese don't have our scruples around how data is going to be used. And so we're in a global race on AI as well. And so I think, I personally, I think that the more that folks can be aware of these questions, I'm hopeful that we'll be able to make progress on our regulatory side in government, and then also make progress on access to the cutting edge of AI technology to our government.
So someone is asking, and I think they're looking for insight and advice, whether or not you've had direct connection to this or not. But people are asking, can you talk a little bit about I used to work for AI, as it pertains to combating financial crime and its success in doing so.
Sure. So there are a number of companies out there that are startups that provide these services, but also we're coming to a place where new capabilities are out there with AI. And so the main thing that's really important is for financial services, financial institutions, folks who are working on combating fraud and AI to start experimenting and running POCs. It's becoming incredibly cheap and easy to start developing some AI capacity. And if you think about something like Bill.com, Bill.com is a company where you can upload invoices, and they're starting to build out more. They're an example of a company starting to build out more and more AI of being able to automatically read receipts, et cetera. Darktrace and others like it, the AI powered security companies, those are examples of opportunities to fight financial crime. There's a company called FeedZai that develops deep learning for recognizing financial fraud in a series of transactions. Mm-hmm. So it's definitely out there, and there's so much room for more of that to happen. And so, I think it's a really, really exciting time to invest in this space.
So someone is, a couple people have signed on to this too. This will be the last question. But they've thanked you for the presentation, and they wanted to know that you mentioned, they wanted to know about the human component. And I think they're bringing up a real, that sort of bias in the algorithms, bias in data, and they're talking about how do we account for Silicon Valley being what it is, a more inclusive race, gender, kinds of way of coming up with algorithms and programming.
So if you have time, I can give a whole other talk, but to be fast about that, I think that our AI is a reflection of us. So our society is biased. But what's beautiful about AI is it gives us an opportunity to raise a mirror to ourselves and to become less biased, because what we need to do is have a system of record for what data trains an algorithm. Then when we see the results of the algorithm, we can improve it by including additional data. And so if we know, hey, this algorithm is biased in particular ways, we can potentially change it to make it more fair by including additional data that wasn't included before. And with Silicon, I think the other piece is it's really important to consider AI ethics policies. Google has one. My company is developing one, and it's something that I think any company that's starting to build AI can start creating those policies. They can create data audit policies. And then again, if they have that system of record, that's another place where regulators can come in and help to support investment in more equitable algorithms, which again are going to depend on that data.
Well, please join me in thanking Nathana for her time, for this great speech.
Thank you. Such a pleasure.